Hi everyone, this optical frequency noise analyzer can fully characterize the spectrum purity of the laser source based on power spectrum density. It's specially designed to analyze the frequency and phase noise performance of narrow line-width laser sources. The spectrum purity of a laser source is the most critical concern along with the evolution of digital coherent transmission and sensing system. And highly functional laser sources, such as ITLA, are facing the issue of optical frequency fluctuations arising from dither and EMI problems. All these narrow line-width applications need to evaluate the noise spectrum performance. Today, let's test this tunable laser source for each frequency noise. We connect the laser source output to the input of optoelectronic converter. The converted RF signal is transmitted to the input of the regular signal analyzer. The dedicated software can control the converter through a USB interface and further capture, analyze the RF signal, and then further characterize the laser source performance. We start the software and enable the laser source output. Click the polarization settings and try to adjust the channel 1 and 2 and choose mode 1, 2, or 3 to get the maximum power. The current maximum power is about 17.6 dBm. Then we set the measurement bandwidth to 510 MHz. The RBW is set to 20 kHz. The measurement points and average times is set to default. We click the Start button. The measurement process will last about 1 minute. You can see the process bar at the bottom. Now we get the test curve of frequency noise versus frequency. We can change the color to green or others. In the analysis setting label, we set the start and end frequency to 10 and 80 MHz. Click the calculation button. Then we can get the line width of 0.893 kHz. The data can also be saved using the Save icon. And you can also record the saved data for further check and comparison. That's all for today's test. Thanks for watching. Follow my channel and see you next time. Bye.